Exercise is a potent physiological stimulus for growth hormone secretion, and both aerobic and resistance exercise result in significant acute increases in growth hormone secretion. Growth hormone is a 191 amino acid, single-chain polypeptide that is synthesized, stored, and secreted by somatotropic cells within the lateral wings of the anterior pituitary gland. Growth hormone is a stress hormone that raises the concentration of glucose and free fatty acids.
They are responsible for the growth and development, metabolism, sexual function, reproduction, and mood. The growth hormone helps to also preserve lean body mass and increases loss of body fat. However, levels decline with age, but high-intensity exercise, adequate sleep, and a diet that contains moderate amounts of protein and a few high glycemic carbs will help maximize growth hormone levels and keep a leaner body mass. A growth hormone deficiency can result in things such as depression, anxiety, weaker muscles, weaker bones, tiredness, and other things.
Our thesis before research studies is the belief that growth hormone is secreted more during aerobic exercise than anaerobic exercise. The release of growth hormone from the pituitary gland into the brain is increased with aerobic exercise, especially more intense training such as interval training.
Aerobic means with oxygen and anaerobic means without oxygen. Aerobic requires more oxygen but over a longer period of time, and anaerobic requires less oxygen but is used up very quickly.
With aerobic exercise, oxygen is carried through the breath to the muscles, giving them energy needed to sustain the effort. Oxygen is not presented with anaerobic exercise. If you are working aerobically, that is going to take up more time and oxygen compared to lifting weights in a shorter amount of time. We are thinking more oxygen intake means higher growth hormone secretion. Both anaerobic and aerobic exercise have positive effects on the body. Both have unique and collective positive correlation towards improving cardiovascular health. They also have been proven to significantly increase growth hormone levels in females. But both types of exercise must be performed above the lactic threshold to induce growth hormone secretion.
Boson conducted a study to examine the effect of growth hormone injections in an immobilized limb. They found that in limbs that are inactive and injected with growth hormone, it stimulates a collagen expression in skeletal muscle and tendons. Without the injection of the growth hormone, there would be little to no collagen expression since the limb is immobilized for an extended period of time. This shows that growth hormones have a positive effect on the body when injected. However, it does not side with a specific type of exercise in this instance. Also in this study, anaerobic isometric knee extensions were used by applying gradual increases of force up to maximum over a 10-second period, and all measurements were performed on the one side, which is the immobilized side. The patellar tendon is impacted positively when the growth hormone is administered, even though there is no activity. Immobilization of the limb causes a little bit of a decrease in growth hormone levels due to the inactivity in the beginning. Growth hormones have a positive effect on the body and do more than what we previously thought. This shows that even with inactivity in a limb, the hormones continue to work and preserve the body. Another study, this one done by Calixto, shows that the growth hormone was highly responsive to the resistance training. Growth hormone was more responsive to slow eccentric velocity rather than quick concentric or even quick eccentric. This is due to the higher metabolic stress. Also, the study concluded that the exercise-induced growth hormone secretion was very different from the normal secretion. In a study that was done by Rackover, they tested the effects of aerobic and anaerobic exercise on growth hormone secretion in adult females. Growth hormone levels were higher in anaerobic exercise, but not by a significant amount.
Kurum University conducted a study to show that HCE hybrid training cycle ergometer resistance with aerobic training provides sufficient exercise to stimulate the secretion of growth hormone and lactate. Growth hormone and lactate are indicators of adequate aerobic training intensity, which reflects enhancing lipid metabolisms. Results of the study showed that the HCE resistance plus aerobic training was more efficient in stimulating acute increase in growth hormone and lactate than regular aerobic training at the same workload. If we combine electrically stimulated resistance exercise with aerobic exercise using HCE, this shows fast increase of growth hormone. Growth hormone correlates with changes in the muscle size and strength. Therefore, growth hormone responds after resistant exercise and shows adequate exercise stimulus. Study done by American College of Sports Medicine was designed to investigate the role of two effective releasers of growth hormone, GHRH, growth hormone releasing hormone, and GHRP2, growth hormone releasing peptide, during exercise. The data indicated that under strenuous aerobic exercise, endogenous growth hormone releasing hormone activity causes a further increase of growth hormone release. Growth hormone releasing peptide mediated mechanisms in the central neuroendocrine regulation, which acts as a booster, possibly by stimulating the effects of growth hormone releasing hormone and or an unknown factor, as well as stimulating the pituitary growth hormone release directly. Initial studies of the growth hormone response to aerobic exercise reported that growth hormone release occurs as a result of exercise, with the initial elevation of growth hormone observed approximately 15 minutes into exercise and peak values attained at or near the end of the exercise. Recent studies using more frequent sampling techniques to measure the inherent pattern of growth hormone release support the contention that aerobic exercise of appropriate intensity and duration is a potent physiological stimulus of growth hormone release in young adults. Kurum University suggested exercise intensity is a key modifier of exercise-induced growth hormone release. They also suggested that a threshold of exercise intensity may be necessary for growth hormone release. In contrast, their recent studies from a laboratory indicated that the magnitude of growth hormone release rose linearly with increasing intensity of exercise in young men and young women. They also observed that the incremental increase in growth hormone release with increasing exercise intensity was greater in young women than in young men. They also suggested that in their recent studies, they'd shown that a single acute aerobic exercise session results in an increase in growth hormone release during and immediately following exercise. The effects of the acute exercise on the 24-hour growth hormone release were not well described, but they also described a transient decrease in growth hormone release was observed following the increase in growth hormone secretion associated with a bout of aerobic exercise. As a result of 24-hour integrated growth hormone concentrations, they were not usually elevated by a single bout of exercise. However, they had shown that 3 30-minute bouts of exercise, separated by 1 or 3.5 hours, resulted in 60% of increase in their 24-hour integrated growth hormone release compared with the control day. Repeated bouts of exercise within 60 minutes of each other did not result in an exercise-induced growth hormone release, suggesting that exercise may break through growth hormone autonegative feedback. When the 24-hour time frame was further divided into day and night, the daytime growth hormone was increased by approximately 150% compared with the rest, whereas the nighttime growth hormone was not different from the exercise or rest. In conclusion, we have changed our thesis to believing both aerobic and anaerobic resistance exercise result in significant acute increases in growth hormone secretion. In the studies we have explained, they have showed results leading a greater increase in either anaerobic training or in aerobic training. And if there were an increase, there wouldn't have been a significant increase to change the argument if one exercise secreted more growth hormone than the other.